Okay, last problem, number 9. In this problem, you're given a velocity versus time graph. Part A says, describe a situation that would create such a graph. So you have to decide what is actually happening with the motion in this problem. So let's start off by analyzing the velocity. At a time of 0, where this graph begins, your velocity is way up here. So on this velocity graph, your origin is down there. Anything above that origin will be your positive side, anything below your negative. Meaning at a time of 0, this object, whatever it is starting with a positive velocity. As time goes on, you see that velocity drops until it's right here. At this time in the middle of its motion, its velocity has dropped to a speed of 0. Once it reaches the speed of 0, it continues to drop until the very end. We end up here at a negative velocity. So now you have to think of what this object is doing. It starts at a positive velocity and gets closer and closer to 0 until it reaches 0. So during that first half of its motion, this object is slowing down until it comes to a complete stop. Once it reaches that speed of 0, it doesn't stay at the speed of 0, it doesn't stay at a stop, it immediately flips directions and starts going in the negative direction. So it starts to speed up as it turns around and goes down in the negative direction. Your job for part A is just to give me a description of some sort of object, whether it be a person, a ball, a car, that would do that sort of scenario. So it's moving in the positive direction and slowing down, and then immediately speeding up in the negative direction. So just give me a written description of an object that would do that. Part B to this is that we have to make a position graph and an acceleration graph that matches that velocity. So what we have to do is start off with a positive velocity, go to 0, then go to negative. We have to show that on this position graph. The first step to that is to decide where you start out. Now, nowhere on this velocity graph does it tell you your starting position. So really, this part is up to you. I'm going to say my starting position for my graph is at 0, just because that's our standard. It's starting off with a positive velocity. That's what we saw on our velocity graph. On a position graph, what that means is you have to start off with a positive slope. So from 0, we know this position is going to go up. So I'm going to have a line starting going up. Over time, our velocity slowed down. So that positive slope that we had on our position graph, over time is going to get gradually more flat until it's completely flat, like so. At this time, halfway through the motion, we're right here. We're at that time where, on the velocity graph, it was going a speed of 0. What happened after that is it flipped directions and started to immediately get faster in the negative direction. So from halfway through that motion, we then start going downward and getting more and more steep as it goes down. What you end up with on your position graph is that little hill. We've done problems like this before, so hopefully that's looking familiar now. Alright, that's it for the position graph. For acceleration, we're using the slope of your velocity graph in order to make this acceleration graph. If you look at the slope, it's constant. It's a straight line going downward. So not only do we know that this line is constant slope, but we know it's going downward, so it's a negative slope. What that tells us is that your acceleration is constant and negative. So we have to show that on this graph. If 0 is your origin, we have to go below 0 in order to be negative. We have a constant negative acceleration, so it's just a flat line on that negative side of our graph. That's it for number 9. So make sure you give me that description of the object, Get your graphs drawn, and that's it for the assignment.
You good?
Mm-hmm.